Do you want to learn how to make sure that your lambdas are optimized for cost and performance? In this video, that is exactly what I'm going to show you how to do. Hi guys, my name is Sam with Complete Coding, and in this video, I'm going to be showing you two different ways that you can optimize your lambdas to make sure you're getting the best performance, but also keeping the cost manageable. So the two options that I'm going to show you today are using the Lambda power tools to enable you to tune your lambdas by running a command in the CLI or inside your CI/CD process. The second option is to use a platform like Sedai, which is able to both monitor and optimize your Lambda configuration for either performance or for cost savings. The first way to optimize your lambdas is to run a Lambda power tuning script, and this is a script that is publicly available and has actually been built into something called the Lumigo CLI, which is a set of tools that make working with serverless easier. The way this works is it spits up a step function, and in that step function it's actually triggers your Lambda function a number of times. It then monitors how long each invocation took. It then modifies the amount of RAM assigned to that Lambda and reruns the test. At the end of this, you end up with a graph showing how long the Lambda took to run, depending on the amount of RAM, and also the cost. It can then even apply that optimum memory configuration to your Lambda. So if you do this in CI/CD, you can have all of your lambdas optimized automatically. So let's jump onto the computer and we can have a look at how we can use that Lumigo CLI and get a result looking like this graph. To demonstrate the different ways of tuning our Lambda, I have set up this repo. This is a pretty basic serverless repo, but the one thing I have done is I've created three separate lambdas. The hello is just the default one, but then I've created one called long wait. And if we look inside that handler, all it really does is it waits for 5 seconds and then it returns. The other kind of lambda is the compute heavy. And in here, we have a while loop that will loop over 5 to, I think it's 5 to the 8, so that's 500 million times, and then return. So in this case, the more RAM there is, and the more CPU there is, then the faster this will run, and therefore the quicker the Lambda will return. I've done this to demonstrate how different kinds of functionality that run inside your Lambda can affect what is the best performance metrics to use. So to actually be able to tune these lambdas, I'm going to be using something called the Lumigo CLI, which is a set of tools created by Lumigo which make doing loads of things in serverless a little bit easier. If you haven't used this before, you can run npm i-g lumigo-cli, and that will install the Lumigo CLI. Now that that has finished installing, we can run the Lumigo CLI command, which uses the Lambda power tools behind the scenes. I'm going to paste this in and then talk through what each parameter does. So the first parameter is just calling the Lumigo CLI, saying that we want to use the power tune Lambda functionality. We then have to set our region. So because this project is using EU Central 1, that is the region we need to set. And now we need to set the name of our Lambda. So if we actually look into here and find my long wait Lambda, that's called long wait. But one thing we need to make sure we do is also include the name of the package as well as the environment. And the quickest way of doing that is if you head over to your AWS console, go into Lambda and find your most recently modified lambdas. Here you can see the full name. So in this case, it is SLS v3 because that's the project, dev because that is the environment, and then long wait. We just need to make sure that the whole function name as it's shown here is used in this command. Now you can set the strategy, and in this case I'm going to set it to balanced, which means it works out a good compromise between speed and cost. And the final thing is -i5, and that is how many times do you want to run the test for each different memory configuration. You can by default remove this and it will run it for 100, but for now I've just left it at 5 so that we can get a quick result. When we run this, if this is your first ever time running it, it will actually deploy the AWS Lambda Power Tuning application to your AWS account, and then it will start running a state machine, which is basically a serverless step function, which will test out all of the different configurations. If we head across into AWS and we search for step functions, we should be able to see there is a power tuning state machine, and in here we can see that there is something that is running just now. If we open this up, we can have a look, and what is happening is it is started and it is now going to execute, which is where it is going to trigger the Lambda for each different memory size and then process how long it takes, how much that costs, and store all of that data. If there is an error, so if your Lambda times out or something like that, it will go to the cleanup on error and then will end. That is one thing you do need to make sure you check, which is if you have the Lambda and, for example, the timeout is 6 seconds, will your Lambda time out if it is run with 128 megabytes of memory? In my case, I know that it would because we're waiting for 5 seconds and the compute heavy actually takes quite a long time. So what I've done is I've added a custom timeout of 300 seconds to the compute heavy Lambda. Once this has finished, you can actually see that you get some information saying the power optimization was 128 megabytes. The cost was a very fractional amount of money, and the duration is always going to be around 5.004 seconds on average. That's kind of unsurprising as we wait for 5 seconds, so the 4 milliseconds is just the extra processing that needs to go on. The state machine that did run, because we are running the Lambda multiple times, does actually have a bit of a cost. So this has cost us 0.03 cents. There is a Lambda cost and a link to the visualization. If you want, you can just in here select yes to the visualization, and this will open up the Lambda Power Tuning results. So with this, because we have just a static 5-second wait, it basically doesn't matter, if you look at the red line, how much RAM you use, it will always take 5 seconds. You can also see the blue line, which is the cost to run this. And as you can see, because you're using more RAM, it costs more for the same amount of time, so the price is increasing. I've run the same thing, but for the compute heavy one, and if I open that, you can see a very different kind of graph. So here you can see that the red line, which is how long did it take to run, is decreasing as you increase the amount of RAM, because the more RAM there is, the more compute power you have, and therefore the quicker it can be processed. There is, though, an increase in price right at the end, so there is an optimally efficient amount of RAM, which is 1536 megabytes, which means that your cost will be minimized whilst also minimizing the time. In most situations, your Lambda, if you're calling other people's APIs, but also doing some compute, will lie somewhere between this example, where the time decreases as you increase the RAM, and this example where if you're always just waiting to call a third-party API, then it doesn't really matter, and therefore the smallest amount of RAM is probably the most efficient. The one challenge with using something like the Lambda power tools is that if you're deploying very frequently, or if you have lots and lots of Lambdas, then either running this script manually becomes completely unmanageable, and if you have it in your CI/CD, it can actually make your deployment process far longer, as the optimization can take a minute or 2 minutes per Lambda, which with 50 Lambdas, you're now talking about 2 hours waiting for the optimization to finish before you can actually do the next deployment. A better approach when you're getting to larger scales is to use a platform to automate this, and one such platform is SedDai. This platform uses machine learning to monitor your Lambdas and then calculate and optimize the memory configuration, all without having to cause extra delay in your deployment processes. This tool actually has loads of other benefits, but let's jump onto the computer and I can give you a tour and show you what information it can give you and how it can automatically optimize your Lambda deployments. When you first open up the app, you see the history and what the recent activity that has been happening in their account with their infrastructure. On the left, you can see that we have discovered 7,000 Lambdas, and this is the generic traffic pattern that we're seeing at the moment. From an optimization point of view, if I go here we can see a list of Lambdas, and if we pick one, we can see that we have an improvement of 82% in duration. So it used to be 679 milliseconds, and after optimization it went to 120. So over a period of 1 month, we've saved 57 minutes of invocation time. And the cost, we can see, is increased by less than $1. And the optimization we did is we went from 256 megabytes to 1.26 gigabytes. So the memory went up, but there was a sweet spot between the price and the performance. Here we have the complete list of hundreds of Lambdas, and all of them, you can see there is an increase in performance. The cumulative decrease in Lambda execution time is almost 90 days. So this is the report you get once optimization is done. But how do you set up the optimization? Here you can see that the customer has a bunch of AWS accounts, and if we pick one, we can go into the settings and we can by default say that we want to optimize everything, and we want it to be auto applied, and we want to target a decrease in duration but without increasing the price by more than 25%. This is what you need to tell the platform so they can figure everything else behind the scenes. Once you apply this, it takes about a week to collect the data and run through the optimization process. Once the optimization is done, you get that report we were looking at earlier, showing the optimization for each Lambda. The other thing that we talked about earlier is release intelligence. Here, if we look at the different projects, we can see that for this project there were 4 releases. And once we go into here, we can see the different releases and how they have scored. So here we can see that all of the recent releases were good, so they get a score of 10, which means after the release, there was no significant change in duration or cost. So that is a good release. Also, because there were no added errors or nothing broke because of this release. If we go back in time, we can also search for moderate ones. And here we saw some releases where there was a slightly shorter duration on some of the lambdas. A shorter duration doesn't necessarily mean that there has been an improvement. Sometimes there might be an error that is thrown early, or something else has gone wrong inside the Lambda, which is causing the shorter duration. What this app does is it lets you know that there is an unusually shorter duration, so that you can then investigate and decide whether that is good or bad. This is a really powerful feature in terms of release intelligence, because you now can quantify how good each release was, and you can also get early warnings when there's a Lambda that has changed unexpectedly, so that you can resolve that as quickly as possible, ideally before your users have ever experienced any issues. In this video, we've looked at two different ways to optimize our Lambda configurations. The first is using Lambda Power Tools to manually, using a CLI, run some tests on those Lambdas to find the sweet spot between performance and cost. The second was using a platform called SEDI, which is able to monitor and optimize our Lambda configuration automatically behind the scenes without us having to get our hands dirty. If you are interested in finding more out about the SEDI product and how it can help you in your business optimize your Lambdas and reduce the amount of operational management, then check out the link in the description below. If you've learnt something new in this video, make sure to smash that like button, as it really helps share this video to more developers just like yourselves. And if you want to know more about the Serverless v3 that I used to create this repo, then check out this video here, where I tell you the need to know information about the new Serverless version 3.